Hello guys, welcome back. So in the previous lecture we have seen how we can implement the remove method. We have understood the steps like the pseudocode which I have provided you in the previous lecture. Okay, so this was a sort of pseudocode with the help of which we are going to implement the remove method in this lecture. Okay, or what I can do is, see, we have already seen the insert method in one of the previous lectures, right? So let's go back to that code and let's see if we can pick something out from this particular method. As you can see, remove is going to be the same as like similar to this insert method, not exact same but somewhat similar to this insert method. Okay, so let's copy the code from here. Okay, or actually copy this whole thing from here. Okay, so if you want you can take a screenshot of this and or if you want you can code along with me. Okay, anything is fine. So if you haven't watched the insert video, if you want you can watch it, that's up to your personal preferences, but here again we are going to write it, so that doesn't matter at all. Okay, so let's write remove. Okay, here we are going to pass the index, we are not going to pass the value. Okay, as per the pseudocode, remove accepts only index, right? If index is 0 or if it is greater than or equals to length, then we have to return undefined, right? So let's change that a little bit. It's greater than or equals to length, then we have to return undefined. That means we have removed nothing from the linked list, right? Now if index is 0, okay, in the insert method what we have done, we have used unshift method, right, which basically adds an element at the very beginning. Okay, so here instead of adding an element or adding a node, what we have to do is we have to remove a node from the very beginning, right? So in that case we can make use of our shift method. Okay, and then we have to remove this bang bang operator. So this one is going to return, I think, the removed node itself, so we don't have to change anything. So if we use shift method, then it is going to remove the it is going to return the node which is getting removed from the linked list, right? So yeah, let's remove this. Oh sorry, I think I've changed the insert method. Okay, I have to remove it from here, right? Yeah, so let's remove this, and here if the index is this dot length -1, that means it is a last node index, right? Because our linked list is 0 based. So here we will check if the index is similar to the last node's index, that is length -1, then we are simply going to pop the node from the very end. Okay, so here instead of shift, I think we have to pass the index, right? And then here also we have to pass the index, if I am not wrong. Okay, we don't have to pass anything in this, sorry guys. So if we are doing shift and pop, that means shift is going to remove the node from the beginning, so we don't have to pass any index. Pop is going to remove the node from the very end, so we don't have to pass any index. Okay, so these are the three edge cases we had to handle and we have handled successfully. Okay, in case of remove, if the index is invalid, we are going to return undefined, as you can see here. If index is 0, we are going to remove the first node without thinking twice. If the index is last index, then we are going to remove the last node without thinking twice. Okay, and for that we already have this shift and pop method. Okay, if you want I'll show you the code of shift and pop as well. If you want you can take a screenshot of it. Okay, this is shift method, and then let me quickly take you to the pop method as well. So this is the pop method. Let me zoom out a little bit. If you want you can take a screenshot of it and then you can write it on your own. If you haven't watched my previous videos by any chance where I have discussed about these methods. Okay, so yeah, let's quickly move to the next step here. Okay, so we have removed the node from the beginning, we have removed the node from the end. What about the middle ones? Okay, so here only we are going to handle the middle nodes. Okay, so same like insert method, we are going to fetch the particular index -1. Okay, so let's say, where is my linked list? Let me see the example quickly. Okay, so let's say we have this linked list, right? And if you want to remove this node, So what we have to do, whatever index we are going to pass, right? So we have to search the node at index -1. That means the previous node on the current index passed. Okay, so this is going to be the current index -1 node, right? And then what we have to do, we simply have to set this node not next to this node. Okay, this way this node will simply get detached. Right now this node is the next value of this node dot next, right? What we have to do is we simply have to set this node as the next value of this node, and then we are simply going to return this node. So this way this node will simply get detached from the linked list. Okay, and this is how it is gonna work, right? So yeah, so we are going to fetch the previous node. Let's say we have passed 3. So here we are going to search the node which is at position 2, 0, 1, 2, 3. If we want to remove this node, then we will search for the node 2, node at position 2, and then we simply set this node not next to this node. Okay, this way this node will simply get detached, right? So yeah, temp we have previous node dot next. Okay, okay, so this thing we simply have to change a little bit. The length is going to be decremented every time. Okay, so previous node, and here we are going to say removed node. Okay, previous dot not next we have stored in the removed node. Okay, now previous node dot next we have to store the removed node dot next, right? And then here we don't need this line because we are not creating a new node at all. Okay, now we have this removed node and we simply have to return it here. Okay, and then new node dot next, we don't need this. Okay, and this is it, guys. This is all we had to do in order to remove a node from the linked list. See, let's say we have passed index number 2. Here we are searching the node which is at index 1. We are storing it in some variable. Okay, and then what we are doing, that previous node not next, we are going to store the removed node not next, the node which we want to remove. Okay, that node dot next value we are going to store as the previous node dot next, and we are simply decrementing the length by 1. Okay, so this way we can easily remove a node from the middle of the linked list. Okay, so let's say we have these 4 nodes, high, high 2, high 3, high 4, right? So let's see if it is working fine or not, because I haven't tested, right? So I hope it works. Okay, so now new SLL, let's see first quickly what we have here. We have the length is 4, head node is high, tail node is high 4. Okay, so let's clear it. Now new SLL dot remove, sorry, let me clear it, dot remove. Let's pass the index 0, 1, 0, 1, 2, 3. Okay, let's try to remove this high 2 node. Okay, so it's at position 1. Okay, so let's remove the node from index 1 and then let's see what happens. Okay, so see, it have returned being the node which it have removed, right? So high 2 got removed. Now if I see new SLL, as you can see, the length is 3, head node is high, tail node is high 4, head node dot next is high 3. Okay, and high 3's next node is high 4. Okay, high 4's is next node is null. That means the node which we have removed is complete, which we tried to remove, which is this one high 2, it simply got removed from the next node, from the linked list, right? Now let's quickly see few other like the first index and the last index dot remove. Okay, let's remove from the 0th index. Let's see what happens. Okay, high got removed. Now new SLL, if we, I'm doing a lot of mistakes, sorry guys. New SLL, okay, the length is 2. Since we have already removed one node from the middle, so that is why the length is 2. Okay, now the new node is high 3 and the tail node is high 4. Okay, now if I refresh it, so we will again get 4 nodes, right? singly linked list with the length 4. Fine. Now let's try to remove dot what to say, remove 0 1 2 3. Let's try to pass 3. Okay, because we only have 4 nodes, right? 0 1 2, which is this one, and 3, right? Let's try to remove the last node. Basically the last node we are going to remove, which is high 4, right? If you expand it, the tail node is high 4. Okay, now high 4 got removed. Now if we see the new SLL, okay, the length is 3, and then the tail node is set to high 3, and the next is null of high 3. Okay, so that means our remove method is working just fine. Okay, if you want, you can take a screenshot, because I will encourage you to write it by your own. Okay, and if you don't have the code for shift method, pop method, and get method, okay, I'll show you the code for get method as well quickly. You take a screenshot of these methods and then try to write it by yourself, so that you will get better at writing these linked list methods. Okay, the more you write, the better you will get in these things, right? So yeah, this is about remove method. As I've already mentioned in yesterday's post, there is nothing much left. There is just one more method which is left in the singly linked list. So let's quickly cover that method in the next video, and then let's see the time complexity, and then let's jump into the next data structure. Okay, so this is it for today. See you in the next one.